Yeah, I didn't get really, I was a bit tight on time this week and didn't get a chance to prepare slides for today. And also, in honesty, I feel like it might not have been helpful to prepare slides because this is just a really nice whirlwind tour of JavaScript where, frankly, if I were to produce slides, I would have just been copying and pasting from the book. So with that in mind, might as well go to the source. So whoops, sorry. Yeah, let me, I guess, get us started then. So this chapter is the first chapter that talks about JavaScript in Shiny, and I get the sense from this chapter that all the references it makes that it's going to dive pretty deep into, or may dive relatively deep into JavaScript in subsequent chapters. And so before throwing us into the deep end, so to speak, the book gives us a little bit of an overview of JavaScript. And honestly, I've made a few attempts to sort of learn a little bit of JavaScript, and this is honestly, I think, the introduction to JavaScript that I've been needing for some while. I really enjoyed it, actually. I don't know if it would have made a lot of sense had I not made those other efforts to kind of tinker a little bit with JavaScript or not. So I don't know for others if you had a chance. Actually, I'm curious, did anyone else get a chance to kind of look through the chapter? And if so, how did you feel about the content? Is it just me that it felt like it was a good explanation?
I think, well, I was a little crunched for time too, but I got through the maybe like the first half of it or so, and then got overwhelmed because it was such a long chapter.
Yeah, it's a super long chapter. It's a super long chapter and a lot of definitions. Yeah. And anyway, I thought it was good, and hopefully if I can't convey the material, at least I can convey my enthusiasm about the chapter. It was a really good chapter for setting the stage, at least in my opinion. So I guess let's kind of get started. So the first thing to recognize is that Shiny, sorry, Shiny by itself is in large part JavaScript. So if you go, as the author does, to the source code of Shiny, then you'll see that there's quite a lot of JavaScript here. Basically, Shiny is doing JavaScript, writing JavaScript or using JavaScript on our behalf. So thank you for that, Shiny. So there's a lot of JavaScript, and if we want to have any kind of interactions in the page, then the thing we'll want in most cases is JavaScript. So this chapter offers a little bit of an introduction to JavaScript. So I guess the first thing that the book talks about is where you might find JavaScript within web pages or within your web app. And so it has this nice little screenshot that shows that there are a few places that you may find JavaScript within your app. If you look at any page and then kind of use the developer tools. So this is his version of the author's blog, and then this is the source on the right hand side. So you can see here the head tag, and then there's a little script tag where it's importing some script, another script tag, another script tag. So there's a lot of script that's being loaded, and you can load it in a few pages in a few ways. So either you can load it in the head via a script tag, so as we saw in the screenshot. So it looks something like this, where you're loading the script. You can or sorry, not this. You can define some script. Whoops, sorry. You can define some script. Let me see if I can just turn this off so no one bothers us. All right. you can define it, in the script tag like this, where you'd have some JavaScript code that you would write within the page. So you just have a open script tag and then write some JavaScript code, much like you could kind of have a style tag and define, a CSS style in the head of your page. Alternatively, you can do some inline JavaScript, if I can call it that. So imagine you have a button as here. And then one attribute you can have of your button is you can have this function right here. Whenever you have the on-click event that fires, here's a JavaScript function that gets executed, right? So that's a second way that you can bring JavaScript into your page. And the third, which is actually what we saw in the screenshots, is through some kind of sourcing an external file. Whether that file is part of the bundle that's on your device, let's say, or it's being fetched from a content delivery network, a CDN, but basically a script tag that points to where the file exists, right? So the three ways: a script tag in the head where you write some JavaScript, inline JavaScript, and then external. So it's essentially kind of like CSS, right? So CSS, you could write a class in a style tag. You could have inline CSS, or you could load an external CSS style sheet. So same principles apply here. And the author says, the best, one could ask what the best method is, and the answer, as with lots of things, is it depends, right? It depends on what you're trying to do. Okay, so that's a little bit on how you might load JavaScript into a web page, and Shiny being a web page, like a web app. Now, a little bit about JavaScript and how you can interact with it if you want to tinker with JavaScript. So we saw, I think in previous chapters for CSS, how you can play with CSS. You can do it through, for example, the developer tools in the browser, changing certain CSS properties, or by modifying pages and reloading the page. So you can see its effects. This is kind of the idea here is to see how you can do something comparable with JavaScript. Now, there are a few ways that you can work with JavaScript. And broadly, like, either you can use Node, or you can use R. And the author kind of favors, and then lastly, like maybe like another development environment. So if you want to use Node, then you have to have Node. So this is like Node.js, right? Node.js installed on your computer, and then if you haven't installed it, think of it as kind of like the JavaScript equivalent of R to a certain degree, right? So it'll execute JavaScript code for you, right? And just to see if it's installed, you do something like this to see that it's installed. There's an alternative here that the author mentions. Option number two, which is kind of like so either you use Node, that's option number one. Option number two is you find an IDE, so integrated development environment. And here there are kind of two choices broadly. Like you could either use Visual Studio Code, which the author recommends, or you could use RStudio. The author kind of points out that Visual Studio Code has better integrations for JavaScript than RStudio does, and for that reason favors Visual Studio Code. There may be other kind of modern text editors that are the same, but I think the big name in town is VS Code now that Atom is gone. So VS Code. So in that way, you can kind of write JavaScript, execute it, and really what you want to do is have like a what's called like a REPL, where you can write the code, it executes it, and then it prints the results in the terminal. So you can kind of see for the JavaScript that you're writing, what's the effect of the JavaScript. So here's an example. This is Visual Studio Code. So let's say you just wanted to console out, to log out hello world, very basic example. So this is the first script you want to do. This is how it might look in Visual Studio Code. So on the one hand, here you would have your script. So this is the JavaScript file, and then you could run the JavaScript file. On the right-hand side, you basically see a console that's running the JavaScript file. So you can see here it's using Node. It's pointing to the JavaScript file somewhere on the author's file system, and then you can see the result here, hello world. And then on top of that, you get to see some kind of metadata about the execution. So it executed with code 0, so everything's okay. And then it took this number of seconds. So that's kind of useful for if you're running JavaScript. And then if you want to run JavaScript, the author points out in VS Code, you have here in this interface this little triangle at the very top that's kind of the equivalent of the source button in RStudio. So it'll execute the code. And here's a comparable thing in RStudio. Okay, so the two environments in which you can run JavaScript. These are not like tons and tons of details, but it does give you a sense of, if you want to explore more, what you might need for a setup, and then where you would want to run things. The author seems to favor Visual Studio Code, but you can do the same in RStudio. Unfortunately, I don't really have a good example of how to do this in RStudio. Like the author, I tend to favor Visual Studio Code, even for running R these days. But that's another story. Now we come to the kind of the basics of JavaScript, and this is kind of a very big, long overview that's really pretty nice. That I think is a good, it's a long introduction, but if you want to dig deeper, I would kind of advise you to maybe read this chapter, and then I can point to a few other resources if you want to go deeper. But this is a really nice, helpful overview that gives you a sense of how JavaScript works. So JavaScript, first think about JavaScript has types, right? So let's kind of look at the, if you want to build something with JavaScript, think about, everything that exists in JavaScript is a bunch of Lego blocks. Well, these are the different colored Lego blocks or different shaped Lego blocks with which you can build things. So first, let's think about the types. So first thing of note is that JavaScript only has a number type. It doesn't make the distinction like R does between integers and reals. It's just or integers and doubles. Just numbers are numbers in JavaScript. You have strings, and then you have Boolean, true or false. There may be a few other things, but these are the main things that you're going to look at. This is actually what's helpful, by the way, about this chapter is I feel like there's a lot that one could learn about JavaScript, and the author, even though the chapter is long, the author doesn't overwhelm you with all those options. He really zeroes in helpfully on the things that matter for working with Shiny. So, this is a good starting point for those who want to work with Shiny. And then if you want to inspect some object, you can see type of. So note it's not a function here, but it's kind of like an operator, I guess he calls it, where you can see the type of something. So in R, if you wanted to do type of, it would be type of with opening parentheses. Not the case in JavaScript. JavaScript, it's as you see right here. So type of and then something, some object. So variables. Oh
hey,
yeah,
Arthur.
go ahead, Trevin.
Yeah, before you go on, I was just thinking, like, is there a benefit of having just number type versus like integers and doubles? I'm just thinking of like what the pros and cons of each one would be. Maybe having just one number would make things simpler, but
yeah, that's a good question. I mean, I guess it depends on what you want to do, right? Maybe with R, they have different types because data are kind of stored in different ways, have maybe different levels of precision, different kind of storage on disk, amount of storage on disk, and maybe that matters for that kind of area of needs. For JavaScript, I guess someone when they conceived of the language deemed that a number is a number and that's okay. But yeah, I mean, you wouldn't be able to distinguish without writing more code. You wouldn't be able to distinguish between something that consists either a thing that is or consists entirely of integers, as compared to a thing that is or consists of, maybe a mix of different kind of numeric storage. Yeah, I don't know.
Yeah, I was thinking maybe precision applications as well. Yeah, maybe that's like something. I know there's like a JavaScript for data science book, but I don't know if that's like a consideration and how it can be applied to data science applications.
Yeah, Lucian and I started reading that book, and we ended up stopping, but no reflection on the book. It's just we had like not so much membership, and one person had to bow out. And we didn't get that far. I mean, I guess we were kind of like JavaScript basics, but that book goes kind of deep. Hopefully it'll deliver on that kind of stuff. I do wonder on like the number stuff if JavaScript's just invented a different class to deal with these kinds of problems where those problems arise. Yeah, I don't know. That's an interesting question.
Yeah, thanks. It was just like came up and
No,
I
no,
was
no.
curious.
That's a cool thought. Yeah. Yeah, marching, I guess, dutifully forward to variables. So in JavaScript, a variable can like consists of three things. It's defined by three things: a type, a name, and then a value. And there's some rules about names that are maybe not too far off from the rules about names that R has. Just know that JavaScript has rules about names. And I think there are probably conventions in JavaScript. I think probably you'll see a lot more camel case than kind of snake case that you might be accustomed to in R. But I think it's a matter of convention rather than a matter of rules about naming. And so there are a few different kinds of variables that can be useful in different ways. So one way that so there are a few ways that you can define variables. One is you can make it a constant. As you can see here, this const, you make it a constant. So basically you define a value and the value of that variable can't be changed. So here, if you define it n equals 1 and then you try to redefine it n equals 2, you get an error and so forth. There's another way that you can define variables with let. And you can see here that yeah, so you let my variable equal this, and then you can define it as this. And then there's a third way to define variables. And really, I think the main difference you want to find is between let and this other one called var. So you can also have var I equals 1 to declare variables. And so you may be wondering, like, what's the difference between let and var? And the difference is scope. So with var, basically the scope is going to be global, whereas with let, the scope is going to be within the scope of its kind of definition. So to unpack that, so let's look at this code example. So var I equals 1, and then let's have some block right here. Imagine this is a function. And then you have var I equals 2. And then if you log out what the value of I is after this operation, then you see the I is equal to 2, right? So basically, the change made here within a block, within, like, let's say imagine this is a scope, be it a variable or this is a scope. So the change made within this scope impacts the value of var globally within JavaScript. So this could be useful in many cases, but it could also cause problems, right? I mean, imagine in R if the variables within your function kind of showed up within your global environment, right? That could be useful in certain cases, but in many cases, we want those variables just to be kind of ephemeral variables that only exist within the function's environment for doing the function's work, right? And if you want something like that, then you might want to look at let. So let's look at the same example. It's the exact same code, but rather than having var to define the variable, we're using let to define the variable. So let j equals 1. So this is in the global scope. Now we have a different scope. Imagine this is a function. This is a different scope. Let j equals 2. And then if we log out the value of j, after all this is done, we find that j is equal to 1 because the value of j only changed within this scope right here. It didn't change in the global scope. J is still equal to 1 in the global scope. So that's one thing to be mindful of in JavaScript. Conditions. There are a few things. I mean, a lot of this is very comparable to R and to other programming languages. So I guess maybe I'll just focus on the things that are different here. So if you want to check the equality of something, you want to distinguish between these two things. And this is kind of odd. Notice you have 3 equal signs, right? And then 2 equal signs here. So you can say, in this case, when you're having the 3 equal signs, you're checking that, actually, this is a brilliant example right here. So if you had this expression in JavaScript, 5, a number, equals 5, a string, this would return true in JavaScript because JavaScript is basically doing like type conversion, I guess, behind the scenes, and then comparing the two things. So they're deemed to be equal, but you can specify in JavaScript the type of equality that is, not only like the value of something, but the type of something is also the same. So you could have equals equals equals. So if we did 5 triple equals quote 5, then that would return false because 5 is a number, 5 on the left-hand side would be a number and 5 on the right-hand side is a string. And even though their value is equal, their type is not equal. So this is kind of a distinction that's made in JavaScript that leads to this one operator that seem a little odd for us as R folk. And then, for conditions, you have some things that are very similar to R. So if you kind of look at this, if condition open brackets do something, that looks a lot like R, right? If condition open brackets, if true, else, do some set of instructions B, that looks also like R. But there's another thing, there are a couple other things that are available within JavaScript that aren't within R, at least that I know of. One is called the ternary operator. So you find this in a few languages. I know this exists in C#. This also apparently exists in JavaScript. And so basically the way to read this, you'll see that you have condition. This is the syntax. You write a condition, you have a question mark. And then if this condition resolves to true, then here's the instruction. Here's the thing to do if this condition resolves to true. And then colon, and then if this condition resolves to false, here are the instructions to execute. So it's sort of like a shorthand for this, right? And in kind of one line, you can write this, and this is called the ternary operator. And then you have this switch function, where you can spell out multiple cases. I won't go into the details here because the author doesn't, but suffice it to say that there are conditions in JavaScript just as there are in R. There may be different ways to specify those conditions in JavaScript than in R, this ternary operator being one, and the switch maybe being another. Although we have switch in R, I've never used it though. Another noteworthy thing about about JavaScript is that it is an object-oriented programming language, sort of fundamentally an object-oriented programming language. R has object-oriented programming language systems, I guess, as we all know from our our advanced R book club together. And so for object is, you know, defined by kind of like these three things, is like a type, some properties, and some methods. So here, for example, you can construct this object me. So this is the author. Have a property name, property age, a property music, and then a function. So this looks maybe a little bit like, you know, the S3 or R6 type things. And then, yeah, and then you could, you know, console out these things and inspect these properties. Like if you've defined me in this way, you could kind of log out the name, log out the age, log out the music, etc. And then since there's a print method, so you can do me dot and then have the method print name, which is a method that we define within me. Then it'll print out I am and then the name. Doesn't show the result here, but that's what's going to happen. Right. And so basically, you know, the way that you're going to do these things is you're going to have object.property. And the author notes that if you want kind of a human readable version of the object, you can have json.stringify, and it'll give you kind of a more readable version of the object. You can do string interpolation in this way. So you have this $, open brackets, and then kind of the name, or this where this asterisk is an expression. So in a sense, if you're kind of familiar with glue, this may not look too foreign. It's just the only thing that differs here, I guess, is there's no function being invoked so much. This is like a flag that string interpolation is going to happen. And then this is an expression that gets resolved. So for example, here, if you're looking this console out, you know, the ith key, so basically this would get resolved as me, and then, you know, you're looking for the ith key, where you're looping over the keys. So the keys being name, age, music, and then it would print that out. So basically, where you find this flag and then the key, then this string interpolation will happen here, and then within the brackets is an expression. So this refers to a key. So name, age, music. And then likewise with methods. So you've either got syntax object.property or object.method. Any questions so far, or is this okay?
None for me.
Okay, awesome. So JavaScript has, whoops, sorry, I've gone too far. JavaScript has arrays as well. Not too dissimilar from R. You can have arrays of this form that are just kind of one-dimensional arrays. You know, this is maybe kind of like a list in R, because you can see here it can contain multiple types. It's just kind of a container. And so you've got this element 1 and then plop. And if you wanted to, yeah, if you want to log out table, you could. An array could be nested. So you could have an array that contains arrays. So here you can see we have overall an array, first element, second element, third element. And then the second element is itself an array, and that also contains an array. So this is an example of a nested array. And if you wanted to kind of get to return elements of an array, you need to refer to that array by its index. And here's where there's one difference between R and JavaScript, is that JavaScript, like many other programming languages, is zero indexed, unlike R. So for example, if you wanted to get the first element right here, you would have to write this expression nested, and then the index is 0. 0 would return you the first element. Nested index 2 would, 1 would return you the second element, etc. So you kind of have to decrement by 1 the index in your mind if you're thinking in terms of R. And then, like with R, you can also kind of have nested indices. So think about like returning elements of a list. This is kind of the same thing. So this is nested. This is kind of a nested list. Think of it as a nested list in R. So we want the element with index 1, which is the second element. So it would be this. And then for that element, we want the second sub-element. So the second sub-element would be this. So basically this would return the array 1, 2, 3. Very much like nested lists in R. And one thing worth noting is that different types in JavaScript have different methods that are associated with them. So for example, you could see what the length is here. So nested.length. So this is a method for this type, the type here being an array. So we get length 3 because there are 3 elements in the array. And then likewise, you could kind of look at sub-elements. So if I wanted to look at, so if I take index 1, it'll give me the second element of this array. And then I could compute the length, right, which is 2. So these are methods for the array. And the book talks about a few different methods. I mean, it doesn't go into any detail, but I think what's super helpful here is that they point you towards the methods. There are probably tons of methods out there that can do all kinds of things, but it gives you a nice synthesis in the table of the methods that the author thinks would be useful to know about. Length, which he shows above, join, concatenate, and then these other things which have to do with how to remove elements from an array or insert elements into an array. I'll just show a couple examples that have, at least to my mind, not very evocative names. So there's this method called pop, which removes the last element of an array. Don't know why it's called pop, but that's what it's called. So if you want to remove the last element of an array, that's what you use. Shift, which removes the first element of an array. I guess shift to the left by removing the first element. Anyway, these are the names. And then there are other methods as well. So for example here, push would be add an extra element at the end of an array. So if you have table, which we've defined, let's see, where have we defined table? Here. So 1 and then plop. You can add hello, so table, that's the name of the object, method push, so add to the end of the array a new element, hello, and then the result is this. Strings similarly have methods. So if you're dealing with something that's an object that's of type string, you have methods. Sorry, one second, I'm about to see. Sorry about that. So these are the methods you have. Not too dissimilar from R, I guess. Although in R, these would be functions. In JavaScript, they would be methods. So syntax would be like this. So you could do length of a character string, or convert it to lowercase to uppercase, or, and this is the interesting part that's, I think, different from R. Another language I use, Stata, it's the same thing, is that you can concatenate strings with the dollar, with the plus sign, right? So you could have a string plus and then another string, and then you would concatenate the two things. There's some mathematical functions here that are available. Okay, here we go. So I guess this answers your question, Trevin. Is well, it's converting a string to an integer, converting to a floating number. So there's a math, I guess you'd say like library or math set of functions that are available. Or maybe you could do things like coerce things into different kinds of numbers, I guess. Sorry, go ahead. I think Trevin, you're about to come in.
Oh, I was just gonna say, yeah, that makes sense that they would have something like that.
But I'm wondering by the name of things here, and particularly this function, if these are actually string function or string methods, because parse, you're converting a string to an integer. Parse float, I guess it's to a floating point number. Doesn't say what the arguments are. I guess we could always look this up on MDN. Parses a string, okay, and returns a floating point number. Okay, so these are string methods. Anyway, again, there's a lot that exists in math, but these are things that the author has deemed useful. If you want to iterate in JavaScript, you have methods for doing so. So you've got for loops, which are maybe not too dissimilar from an R. There are a few different ways to do for loops here. This is the ES6, so this is so JavaScript is, I guess, one name of things, but I guess formally JavaScript is ECMAScript, and there are different standards of ECMAScript. 6, I think, is the latest one, at least as of writing of this book, and I don't happen to know if it's still the case. This is how you would write it in the, let's say, like the most modern JavaScript, but the author points out that ECMAScript 6 may not be, not all web browsers will interpret ES6. So you'd have to look. I think MDN will kind of give you a sense of where things work on which browsers. I don't know if it's the case. Yeah, at the end of this article, they have this useful table you'll find often. This is, where does this work? I guess the oldest version where this works, and they show for many of the prevalent web browsers. And this is kind of a more classical approach with JavaScript. So here you're kind of saying let I equal 0, and then I guess is kind of implicitly a while I is less than the length of this, and then iterate increment I for each iteration increment I the value of I by 1. Right. There's also a for each method that could help you with iteration. So here you're basically just saying, letters dot for each. This is available for arrays on introduced in ES6, ECMAScript 6. And so basically you just iterate, for each of these elements, it would do something, right? Think of kind of per, basically. Right. While loops exist. You can write functions in JavaScript. I think this is kind of the classic way of doing things. Or no, actually it's not. This is the ECMAScript 6 way of doing things, where you would write a function. Interestingly here, a function, I guess, from JavaScript's perspective, is just an object like any other, is just an object, kind of like it is in R. So functions are first-class objects, I guess. And because we don't want our function to be mutable, we're making a constant. So constant and then function equals, then you have your parameters. You have this little kind of decoration right here, which is maybe a little different than R, but not too dissimilar. We have the opening and closing brackets, but then you have this little bit right here. And then these are all the instructions of what to do. you could all do this. This is an older way of writing functions in JavaScript. And this is the way you'll find functions written in Chinese JavaScript core. So you just write function and the name of the function like this, and then if any arguments, you'll put them inside the brackets. This looks very much like R, right? And the author notes here that this will work everywhere. ECMAScript 6 may not. So this format from ECMAScript 6 may not. And so if you're developing functions, you can also export them as modules. So here, you can imagine you've created this function, you want to export it as a module, you can have some module and then export it in this way, where you've got kind of a name and then a value. So this is the value, this function here. And then you can also import and export. So this is, I guess, the older way of doing things with ES6. You can do something like this. It looks very Pythonic to me, although I've not used Python. Export and then export a series of functions. And then if you're, let's say you're loading a script, you want to import certain functions, import, and then your set of functions from, and then here defining like the file from which you're importing them. Right. One problem that exists in JavaScript, and we're going to get to this in later chapters, the author just cites it here, is that it's a little bit kind of the same problem as with R, right? You have different versions of JavaScript, and different browsers may need certain different versions of JavaScript, or may only run different versions of JavaScript. And so you'll have this problem where you would want to basically write your script in the JavaScript version you want. Like, let's say you love writing in ES6, let's say. But you want to have, ultimately you want your JavaScript to be consumed by a browser in the version in the browser needs. And so this is called transpiling. And there are lots of tools for transpiling, like Babel is very common, Webpack as well. That basically will take as an input your JavaScript, and then it'll convert it to a target version of JavaScript. So if you're targeting, heaven forbid, Internet Explorer 11, then maybe you could transpile your JavaScript so that it'll work in IE 11. This is something we'll get to in later chapters. Also, there's more detail on this in the JavaScript for R book in the latter chapters. I think they start to talk about Webpack. So one common thing that you'll find is this event listeners in JavaScript. When like prototypical use case is something like this. So let's imagine you have a button with an ID, my button, and then you want something to happen when your button is clicked. So in the JavaScript side, you'd want to have a function that looks a little something like this. So you would want to have the button ID. First, you want to fetch the button ID. So you'd have this button ID. It scans the DOM, the document object model, your web page, basically, to get element of the page with this ID. So my button. It'll basically find that thing, and then you can have an event listener that will do something when that object is clicked. So here you could have this object button. You can add an event listener. The first parameter is the event. So there are a few of these events, click, change, mouse over, etc. So let's imagine on the click event, then you perform some function. And in JavaScript, this is called a callback function. So basically this function is called when an event is triggered. So here you can have, this is an anonymous function that basically says, throw up an alert, thanks, when your button is clicked. So that's it for basic JavaScript. I'll move on to jQuery. I see that I'm going a bit long here, so we'll see how much we can do. So jQuery, so this is kind of vanilla JavaScript, which is useful to know, but jQuery is around because jQuery, the author points out, I've never used jQuery, so I just took this assertion at face value, makes writing JavaScript easier in many cases, because it provides a convenient interface for working with JavaScript. So here's an example of where jQuery is being used. So this little script right here is jQuery. So I think when you see $signs like this, you're working with jQuery. So here it's loading in the head jQuery from a CDN, and then we have a little jQuery script. So let's look at the syntax of jQuery. jQuery is a library of JavaScript. So you need to load the library in order to use it. I believe it comes prepackaged with Shiny, but I could be wrong about that. Oh, sorry, I see a few things in chat. Oh yeah, thanks. So basically, it'll be something like this, where you have $sign and then the selector, and then some action that occurs. So you want to select some element or elements of the page and then perform an action. So to kind of give you a sense of how jQuery might be more efficient, look at these two cases. So let's imagine we have a paragraph with this text, hello world. If you wanted to basically select the text, this hello world text, this is how you do it with vanilla JavaScript. So, define some variable with let right here. Let, we'll call it inner, right? Because it's the inner text, inner HTML. So basically, look at the document, the whole page, the document object model, get elements by class name. So look for elements whose class is text. So up here, we've created our paragraph and it has a class of text. So get elements with class of text. And for that element or elements, return the inner HTML. So this, right? So that's how you would do it with vanilla JavaScript. With jQuery, it's much simpler. So again, the idea is you have a selector. So dot text, remember this is how we write classes, CSS classes is the CSS class, dot text, and then dot HTML, and that's it, simple. And the author kind of shows similar ways that you could, imagine you have this unordered list and this unordered list here that have sets of items. If you want to get all the items that are within the list, you could do something like this in jQuery. So this is just a simple selector. Here we're just selecting, we're not performing any actions. So we're selecting everything within the document that has the class list. So these two ULs have the class list, and then class item. So each list item has the class item. So basically, we're going to end up with an array of these 6 LIs. And then you could do other selectors. So this is maybe a little bit kind of like CSS. CSS meets JavaScript. So if you're familiar with the selectors in CSS, jQuery will be relatively straightforward for you, at least as parts of selectors. Yeah, and this is the little gotcha that frequently happens and with jQuery is you could write things like this, but basically what you want to do is you want to write it in one of these two ways, because basically what can happen is that jQuery could run, I think they call this, what is this called in JavaScript? Race conditions. So basically your JavaScript could load before your page is loaded, before the whole document object model tree has been like unfurled. And so what you want to do is you want to make sure that your JavaScript runs only after the page is ready. One way of doing it is this. So basically take the document, make sure it's ready, and then after it's ready, do your code. Or you can do something like this, lots of gnarly parentheses, but this is how you do that. And then if you wanted to kind of do these selectors, there are lots of nice selectors that exist within within jQuery, and here's kind of a list of like a curated set of these that might be useful. You know, the first element that meets a condition, you know, the children of something that you select, the closest thing, the next thing, previous thing, the not, etc. And then you could also so these are for basically ways that you can kind of like traverse the document object model. These are ways that you can manipulate tags. So CSS tags, so you can add a class, select things that have a class, remove classes, etc. Insert content before, so on and so forth. So these are kind of things that'll help you interact with classes. These will help you select elements. These will help you select elements or interact with like the class attribute or tag attribute. And then you can, other thing about jQuery is you can kind of chain it. So you could do lots of things. So for the UL, select the first one, and then add the CSS color. So add the CSS, give it the color green, give it an attribute, give it an ID of awesome ID, item ID. So you'd be adding this to this, and then add a class to it. So you can basically perform all those operations by chaining them in this fashion. Since this is an object-oriented language, just this, then this. I mean, think of these kind of as pipes in a certain sense in R. And one thing that jQuery makes kind of easier than vanilla JavaScript is it makes kind of iteration easy in certain cases, because in many cases iteration is not needed. So let's say, for example, you wanted to do something for each one of these list items. So one way you could write this is you could kind of say, select the list items, and for each list item do something, which would be sort of a translation, a literal translation maybe of what you want to do for select each list item, and for each list item do something. But in jQuery, you can write something a lot more compact. So select LIs. So to select both of these with an array, and then do these things implicitly for each one of the selected elements of the page. So add like this attribute visibility and make it hidden. So this is like writing CSS for these, inline CSS for these, which makes things a lot easier. And then you've got these events that exist in jQuery. We're going to select some element and then have a click event, a change event. Yeah, make sure that the event triggers only once, so only on the first time you click in this case. So one time on the click event, perform this function, etc. Yeah, you can extend objects. I'll just jump over this for time considerations. And one point the author makes kind of in coming to this last chapter, where we kind of we go from a discussion of JavaScript to a discussion somewhat of JavaScript in Shiny. It is, he makes this point that I think is kind of a challenge to me. Let's see, where does he make this point? He basically says that a lot of issues that appear, oh yeah, here we go. A lot of Shiny issues on Stack Overflow could more easily be solved by just inspecting the console. So remember that Shiny is something that we're able to manipulate with our code, but ultimately it creates something that's fundamentally HTML, right? So we're creating an HTML file, a document. We're potentially creating some CSS, and there's JavaScript going on in the background. So if you want to see the inner workings of what's going on, you can always open the developer tools and look at what's going on. And in fact, if you open the developer tools, I guess I'll just do so for this page, you've got this console option. So here you can see what's going on on the JavaScript side. So this might be very useful. So you could kind of like query the page, or they kind of understand the current state of your Shiny app by inspecting it through JavaScript, right? Because again, it's a web page. web page that has interactive elements. And so the author kind of goes on to talk about how you can debug Shiny apps by looking at dev tools and seeing problems that are kind of JavaScript problems. It may have some problem either in the JavaScript that you're passing to the page or in somehow the way that your app is working. And it goes on to point out that you can kind of do some you can also like test your functions here within the console. I mean, you can almost use the browser's dev tools as sort of an integrated development environment if you want it, and that can be helpful. I haven't completed the exercise, regrettably. I was a bit crunched on time, so maybe there's something very useful there. But at least for me, I felt like the main, or like one big value of this chapter is it just gave a really nice overview of JavaScript and jQuery that was useful. It pointed out that I really focused on the parts that were useful for the R developer, or rather for the Shiny developer, and I think kind of left as area for future research for those interested or those in need, like the rest of the vastness of JavaScript and of jQuery. So I'm really kind of eager after this to kind of maybe to the extent I can understand any of this is go and look at JavaScript, the JavaScript that exists in Shiny, and see if I can kind of see some of the things that we've looked at in the chapter here, and then maybe also run one of my Shiny apps or run a Shiny app, and then look at developer tools and see what's going on in the back end. Now, the future parts I think are going to talk about, well, now, okay, great, you know how JavaScript works in isolation in a certain sense. To a certain degree, you understand that Shiny is using JavaScript, but how do you bring your own JavaScript to R? How do you have the two things communicate together? And how could you bring that as like a module or some other thing to JavaScript? And then if you go down that path, what are the other problems you're going to, maybe you'll solve some problems, but undoubtedly you'll run up against other problems. And how do you solve those problems, which are maybe, problems that are problems of the front end developer, which, you and I may not be yet. How do you handle those problems, or at least preempt those problems? So that's all I've got for today. It was just a, kind of walking through this really rapid tour of this long but very interesting chapter. Hopefully it sets the scenes for stuff to come. Again, apologies I didn't have notes, but maybe it was helpful just to look through the book, since ultimately the examples author puts forward are very communicative, and I really appreciate the fact that the author has given us kind of a curated set of things to explore more, or that the author thinks might be useful for people like us, since ultimately the author is a Shiny developer too. What are the bits of JavaScript that it would be good for us to learn, and maybe in time we'll learn other stuff too, but those will be for the future. But at least master the basics of how do you, with jQuery, kind of traverse the document object model. How do you manipulate tags on elements? Those are really useful things. All right, I'll stop there. Were there any questions or comments or anything like that?
No questions for me. Just yeah, thanks for going over this chapter. It was definitely a beast with how long it was, but
Yeah.
you made it seem a lot less overwhelming. So
Yeah, no, it's definitely a lot less. It's a lot less scary than it might at first seem. I mean, I remember looking at this chapter, thought, oof, that's long. But I mean, if you walk through it kind of sequentially, it's really not that bad. It's really not that bad at all. I mean, like, could I, if someone held a gun to my head and made me write something in JavaScript, could I do it? Probably not, but at least I have the beginnings of knowledge. Yeah.
cool.
Cool.
Well, hopefully, yeah, hopefully your work isn't doing that to you. So
Yeah, exactly. No, not yet. I mean, I would like to learn more JavaScript so I can, maybe more have another option of introducing interactions within Shiny, or at the very least, like better understand some of the frameworks I'm using, like Shiny.js. You know, I just kind of take it as magical stuff that Dean Natali put together, but you know, ultimately under the hood, he's just kind of wrapping. I think he's just wrapping some JavaScript or jQuery, so we don't have to know the implementation details. Cool.
Yeah.
All right. Well, I'll see you all next week. I actually don't know. Do we have a presenter for next week?
I have the list up, I think. Let's see.
Nobody yet.
Not yet.
You would think since Russ and I went through this book, or went through a book that dealt with this, that here I would tackle this. We'll see. We'll see.
Okay.
This might be a good. We'll see. Yeah, I might sign up for this. We'll see. Maybe Russ can come back from holiday and just rattle it off too. We'll see. But yeah, it looks like we're still looking for presenters. In fact, I guess since it's a very big book, there's a lot of people that clamored to get spots early on, but it looks like there aren't many presenters for later on. So if there's something that looks interesting to you, put your name down, and yeah, before it gets snatched up by somebody else.
Yeah, I might do the Mastering Chinese events. I might check that one out.
Oh yeah, that sounds like a good one, actually. Cool. All right. We'll see you all next week. Thanks so much.
Bye, everyone. Thank you.
Bye. See you next week.
Bye-bye.